next type of functions we are going to discuss are exponential functions. Sections 3.2 and 3.3. Now, let me first describe what is an exponential. So, the function f defined on the set of reals with values in the reals is called an exponential function. Even if there exists a number a, positive number a, such that the following holds. So we assign to each input variable x, we assign a to the power x. And a is called the base. Now, of course, this has to hold for all real valued input variables x. Now we have a number of laws, so I will discuss these before drawing the graphs of these exponential functions. Now the laws are the following. So laws of multiplication. So if we raise a to the power x plus y, then we get the same result when we raise a to the power x and multiply it by a to the power y. Second law is that if we raise a to the power x and raise the result to the power y, then we can just as well raise a to the power x times y. Then we have that a to the power 0 equals 1 for all positive a. So really positivity of a is quite important. And in fact, what do we have is that a to the power x is always positive, and I think that these are the main laws. Now, to motivate why these laws should hold, we do an example. We consider examples. So take us the example where a is equal to 3, and let us consider x and y equal to 2 and 4. Say we have 3 to the power 2 multiplied by 3 to the power 4. Well, what do we get if we do 3 to the power 2? We multiply 3 by itself, and then 3 to the power 4 multiply 3 times by itself, and we get a total of 6. So we get 3 to the power 6, and if you realize this is the same as 3 to the power 2 plus 6. So the first law over here is quite natural if we consider x and y as positive integers. Now if you have positive integers, you can extend this to positive fractions and positive reals. So now we come to the question why this third law should hold. And this follows naturally from the fact that we want that this relation now holds for all x and y, not only positive ones. So what is the reason then? Well, what should we get? If we have 3 to the power 2, for instance, then this should be equal to 3 to the power 2 plus 0. Natural 2 is 2 plus 0. So by our law of multiplication, this should be equal to 3 to the power 2 times 3 to the power 0. And what you get is 9 equals 9 times 3 to the power 0. So 3 to the power 0 should be 1. There's no other conclusion than that this must hold. And now, why do these laws hold for negative powers? Well, it's not so much of a question why they hold, but what a negative power means. So what is the result of raising a to a negative power? So let us consider now, for example, the problem of calculating 3 to the power 2 minus 2. On one hand, this is 3 to the power 0. On the other hand, by the laws of multiplication, this should be equal to 3 to the power 2 times 3 to the power minus 2. So on one hand we get 1, on the other hand we get 3 to the power 2 times 3 to the power minus 2. So the only conclusion is that 3 to the power minus 2, so we divide by 3 to the power 2 is 1 over 3 to the power 2. So this motivates our further, why we choose 3 to the power minus 2 to be equal to 1 over 3 to the power 2. It's just to make this laws of multiplication work for all rules. So the consequence is that we have the following relations. Put them here. That a to the power minus x is equal to 1 over a to the power x. This is the conclusion of this last line over here. And I had another, oh yes, and if we raise a to the power 1 over n, then we can also write this as the nth root of a. The most familiar one to you is, of course, is when we take the square root of a. This is equal to a to the power 1/2. Now, as a combination of these two, what do we get more is something which many students also tend to forget, that a to the power minus 1/2 is 1 over a to the power 1/2. So it's 1 over square root of a. So these calculations follow directly from the laws of multiplication, but sometimes difficult to remember these. Now I didn't say anything about the second law over here. So raising a to the power x to the power y. So let us consider again an example. So we have these various examples. So let us say take, for instance, a 3 to the power 4 to the power 3. Then by definition this is 3 to the power 4 times 3 to the power 4 times 3 to the power 4. And if you look at it using our previous law of multiplication, is that this is 3 to the power 4 plus 4 plus 4 is 12. And this is the same as 3 to the power 4 times 3, which is again this second law of multiplication. So these are all laws that you should keep in mind.